Go.
Welcome guys, this is a tutorial of 4.3 graphs of the tangent and cotangent functions. So thank you for watching and let's go on with the tutorial. Stay tuned.
Yes. Alright.
Hey, can you do this?
Alright. Hopefully they'll come up on the thing. Alright.
To find out how to do graphs and cotangent functions, keep on watching.
Alright, so let's take a look now. So we're going to go through and actually find tangent, cotangent. Slightly different. So hopefully you guys are following along, paying attention. If you guys need to scoot up, you can. I got plenty of room over there if you need it. Okay, so let's take a look right here. Now, tangent and cotangent has asymptotes. Okay, asymptotes are the MC hammer of math, right? Why is it MC hammer of math? Can't touch this. There we go. All right. So now.
Asymptote.
Anyway, all right. So I'm gonna start this now versus starting it later, because later when I did the notes early this morning, I totally confused everyone. So I'm just gonna tell you where they're at now. Okay. So we know that tangent is what over what? Sine over cosine, or y over x, right? Okay, so what I'm going to do is I'm going to take a look right here at my unit circle, on my fat circle right here. So what is the coordinate right there?
0.
The coordinate, it's what?
0, 2, 16.
I'm hearing different things. It's not 2 pi, the coordinate. What is the point? 0, 1. Is it 0, 1?
No, it's just 1, 0.
It's 1, 0. It's 1 to the right and 0 up, right? Okay, there you go. So it's going to be 1, 0. Okay, this one up here. What is this one?
Are we drawing this?
0, 1.
0, 1. Very good. This one over here. And this one right here.
0,
All right, so from there, I'm going to actually decide where are the asymptotes. Asymptotes is where it's undefined, right?
Yes.
Okay, for these ones, it's going to be where it's undefined. So now, if it's sine over cosine, when is tangent going to be undefined?
When it's 0.
When what is 0?
Cosine is 0.
When cosine is 0. So it's going to be cosine is 0 where?
The
Right on top. What is on top? In radians. What's the unit in radians? Pi over 2. So I get pi over 2. And 3 pi over 2. Very good. So this one, the natural asymptotes are going to be at, okay, pi over 2, 3 pi over 2. But now, because of the way that this is set up, what if I go backwards on this one right here? It's going to be negative what?
Pi over 2.
Negative pi over 2. Very good. It's going the same distance this way as it is going backwards, right? So I could also call this one here negative pi over 2. So my natural asymptotes right here are going to be at, so negative pi over 2 and pi over 2. Now cotangent is cosine over sine.
Yes.
Yes, right?
Wait.
This is what we did back in Unit 1.
Hunter,
Yes.
did you put 3 pi over 2 right there too? Where sine at? You know what I mean?
Right here?
No.
At 3 pi over 2?
Go up.
No, I don't have to do this. You'll see. Ashki, you'll see why.
Not that. Where it says at negative pi over 2. Can
Yes, it can.
Okay.
But we're going to do these ones right here. You're going to see why that I'm only going to use these two right now.
Right now.
I'm going to use these two right now. And if I'm going to do 2 periods,
Yeah.
I would use the next one, which would be 3 pi over 2.
So using this one part.
Yeah, I'm just using 1 period. And that, the period for tangent, it naturally comes up right here. In between these two right here. So that's going to be 1 right there around that. Okay, now, cotangent. Cotangent. When is cotangent going to be undefined?
2 pi.
When sine is 0, right? Sine is 0 where?
2 pi.
At 2 pi. Now, but if I'm going to start this off, this will start off at where? Would this start off at 0 pi?
Yes.
Yes, so I'm going to put 0 pi. So it's 0 pi. Okay, where's the next one going to be?
Pi.
Also at pi, right?
Yeah. Also at pi.
Way to just try to chime in on that one. Good job. Now, you'll understand why I'm doing all this later.
Okay, so it's not going to make sense right now.
If it doesn't make sense right now, I'm just going to say, hey, revert back to this and tell me what these are. Because we're going to plug these in here later.
But what does that first one say? 0 pi?
Okay.
Yeah?
Baby
0
steps.
pi.
Baby steps, let's go.
Yes, okay. So, all right, now, next one. So this is what it's going to look like. The reason why we started off with this, okay, this is the graph of what it is. If you notice, I have asymptotes here, right? I have an asymptote here, right?
Yes.
And if you notice, it's between negative pi over 2 and pi over 2, isn't it?
Yeah.
That's my one graph. This is one tangent right here. This is my one tangent, and my asymptotes are here. So this is normally what it starts off looking at. Then we're going to change it from there. Okay, does that make sense?
Yes.
Okay.
So wait, isn't there another one that's horizontal? Like, aren't there other asymptotes that are horizontal?
No, not for these.
There are, right?
Not for these.
Okay.
So you're not going to have a horizontal asymptote for this because it's a wave. It's going to keep going like this all the time. It's going to keep going. And it's one wave, and it continues on the other side of the asymptote. We're going to do another wave. Okay, where sine and cosine wraps around the x-axis. Okay, this one is actually going here in between the asymptotes. Make sense? Kinda? Alright, so let's take a look at the next one. Next one's going to be, this one's tan. So now, this is going to change our steps here. This is going to change our steps. This piece right here changes our steps. You know how sine and cosine, the natural period is what?
2 pi.
2 pi. This one is now pi. So when I'm trying to figure out the period, instead of saying 2 pi over b, I'm going to put what?
Pi over b.
There we go, pi over
Is it
b.
going to be easier?
Kinda. It's kinda easier. So I'm gonna simplify the steps a little bit for this one. Might be oversimplifying, but it's gonna get everything you need. Now, cotangent is a reciprocal of tangent. So if cotangent is a reciprocal of tangent, that means if cotangent is going up, if tangent is going up, then cotangent is going down. Now, remember what I said? I'm going to reference this back again. Where were the asymptotes for cotangent?
0 pi. Oh, 0 pi.
Where were the asymptotes for cotangent?
A negative pi over 2 and
Try again.
0 pi and pi.
It was on that page I told you to write down. Then that's why I just asked you to reference it.
What is it?
You say cotangent?
0 pi.
0 pi and
Pi.
thank you. 0 pi and pi.
Both undefined.
Yeah, don't even slap hands at yourself. You can't even congratulate yourself. I had to throw something at you just to get your attention. Okay. So here's an asymptote right here. Okay. So I have my asymptote right here, right?
Yeah.
So the asymptote's here at 0 pi. I also have another asymptote where?
Pi.
At pi. Where do you think the next asymptote's going to be?
Pi 1.
2 pi. This is 1 pi. The next one's going to be at 2 pi. Very good. All right.
Oh, okay, okay.
Now,
Why are you going to do another one?
And then 5.
huh? I'm not going to.
That's it.
I'm just trying to give you an example because it's every unit of pi.
It's always going to be a unit of pi, or is it going to be different?
We're gonna do some manipulating of this that it's gonna change it. If we change our period, that means it's no longer gonna be pi. We're gonna it's gonna be faster or slower. Okay? That's where I get my b, my pi over b. And that's what we're gonna be doing. Okay, so now, if you notice, cotangent is going
Down.
when tangent was going
Up.
Thank you. So, next one. So, again, cotangent right here. Cotangent period is going to be pi, right? So it's going to be pi over b to figure out the period. Next one, blah, blah, blah. Blah. Blah, blah, blah. Blah, blah, blah. Blah, blah, blah. Hey, look, I'll tell you right now. If you want to read it, it's actually good information. It really is. But the problem is, you people don't read anything. I can barely get you to pay attention to stuff I yell at you.
You're right. You're right. Reading is overrated.
Hey, don't even play because I had like this. I had my 6-hour class give me like this huge explanation the difference between then and than. Because I accidentally used the then when I should have used the than. And at one point I was like, oh my God, do I really care this much? No, I don't. I'm sorry. All right. So now steps. What's my first step? Find the amplitude. What is my amplitude?
2.
Very good. Amplitude is 1. Period.
Would it just be pi? Or just
Pi.
pi?
4 pi.
Just pi.
Pi over.
2.
Where did we get the 2 from?
Two.
This one right here, right in front of here.
I have a question.
Yes, go ahead.
So is it always going to be pi now, or do we either use?
You tell me. Is it always going to be pi?
Yeah.
Why is it always pi?
But it's changed.
Only when it's tan and cotangent.
There we go. Winner, winner, chicken dinner. Tan and cotangent are always using.
Pi.
Thank you.
And then
Like after you translate,
I don't want to think sine and cosine are using 2.
Excellent. Very good. All right. So now period's going to be 2 pi. So now, we're going to change this up now. What is my b value?
2.
Okay. My b value is 2. So now we're going to do our asymptotes first. We're going to graph the asymptotes. So now, the reason why I kind of didn't want to actually do the video I had earlier, my screen lagged out as I was writing, so it said ASS on there, and it just stayed on there. It wouldn't even erase. And so yeah. Anyway, so asymptote A S Y M. There we go. Asymptote. So I can't spell the whole thing, so I'll abbreviate it. Asymptotes. Now, this is what function? Say tangent.
Tangent.
Because it says
Hey,
tangent.
did you just say cotangent?
Yes, she did.
Oh yeah.
Okay. Okay. So now, where are my asymptotes at?
Pi, negative pi over 2.
So negative pi over 2 times 1 over b.
Wait, what?
Where'd you get that?
Oh, I don't understand.
Because it's the 10.
These are going to be your steps.
Wait.
So no more faces.
It's going to be different. It's going to be different. No, we're still going to have to do that. We're still going to have to do that.
Oh my gosh, dude.
Hey, math is wild.
Negative pi over 2 times 1 over 2. So my asymptote is going to be where?
Negative pi over 4.
Thank you. Good job, Oshki. Thank you.
Does it have to be negative?
Why does it have to be negative?
He's the only one that
Wait,
understands.
is that 1 over b?
Yes, that is 1 over b.
Oh,
Which asymptote am I using?
You're using.
Tangents, right?
Yeah.
Okay, using the tangent. So what's the next one? Okay, what's the next asymptote am I putting in there?
pi over 2.
My next one's going to be positive pi over 2 times what?
1 over 2.
1 over 2, right?
Wait, so what's the 1 over b?
This is what we're doing to actually figure out my asymptotes.
Formula to it?
It's kind of like a formula to this. So, because the cotangent is going to be different. Why is cotangent going to be different?
Because it's 0 pi.
Yeah, it's going to be 0 pi and it's going to be pi, right? So it's going to change it. So it's times by 1 over b. So now what do we get here?
Wait, what is the negative sign?
Pi over 4.
It's period times 1 over.
These are not periods. These are asymptotes. Asymptotes.
Christian, you good?
Where was my first asymptote? Remember when I said you're going to reference back to these? You wrote down two things. Okay? Did you write down those two things?
Oh, no.
Christian, you did?
I did.
You did?
Yes, you did. Yeah.
I did.
Good, good, excellent. Okay, so now I have two asymptotes here.
Okay.
You ready? I have my two asymptotes.
Never mind, I get it. Okay, I'm good. So are the asymptotes just like negative and positive the same value?
No. The reason why, because cotangent is going to be different.
Alright, I got a
No,
question.
I mean like how it's negative 4 over.
As of right now, yes. But we're going to put in some phase shifts and stuff later. Yes.
Where'd you get the 1 over 2?
Where did I get 1 over 2? What does this say?
Is 2.
What does this say right there?
1 over B. That says 1 over B. It's not
1 over b. What is your b value here?
For the variable.
Alright, true. Okay, good.
Where did the first part from though?
b equals 2. What first part are you talking about?
The pi over 2.
Okay, remember when I referred back to this like 30 seconds ago and I said there was something you had to write down and I told you to write it down. I even threw something at you people. Ain't that right, my dude? Okay, there we go. Okay. Now, those things are what we're using for this.
Oh,
So-
is always gonna be those?
We're starting with those and then we're going to change stuff up. So we're going to add more to it. Okay, so right now we're only having that. We're going to change our period. We're going to change our amplitude. We're going to do a phase shift, so we're going to move it all left and right.
We're doing phase shifts too?
Yes, just not today.
Why?
And there'll be vertical shifts.
Oh my god.
That's it, I dropped
Hey, what's the homework doing?
Huh? Okay, so now, are you guys okay here?
For now.
So if I was to go ahead and sketch this, look at my graph. Woo! Look at amazing graph that I just drew right now. So you guys blinked and like totally missed it because it just right there.
Alright, keep going, mister. Okay.
Huh?
We're on a time.
I'm trying. So my asymptotes are here, right?
Yes, they are.
Yes.
That one's not.
No, that's not right.
Give me what I can mix this on.
Yes.
Keep doing my flower on your,
No.
why not?
On your show, what show?
Might take me a few seconds.
On your channel, whatever.
Yeah.
All right, you ready?
Yes.
Okay, listen up, please. Listen up. Couple things are going to happen here. Couple things are going to happen here. So now I have my asymptotes, right?
Yeah.
So I have my asymptote. So now this one's going to be from here to here, right?
Yeah.
Okay, so I'm starting here and I'm ending here.
Yes.
So right in between, directly in between, it's going to be what?
Your line.
My 0, right? Okay, so I'm going to have a point at 0. So I'm going to have a couple things here.
Oh, okay.
So I'm going to show you guys how to actually set up your parts tomorrow. But the uniformity of this starts here. And then right here in the middle of each of these. Okay, so now there's my 1, 2, 3, 4. There's my 4 parts to this now.
So that's where we're putting this. I have a question.
Huh?
Wait.
And then it go down.
One.
Okay.
I only see 3.
1, 2, 3, 4.
Oh, the space in between is what you're saying.
Yes, those are my parts. So think about it like this. If we're cutting up a sandwich into 4 parts, we're not counting the cuts of my sandwich.
Who cuts a sandwich in 4 parts?
Me.
You might want to share it with your homies. And you get that foot long.
Who shares with your home?
Okay, anyway. All right, go ahead. Just stop right there. Hey, Adrian, you had a question?
I do.
What?
It ain't gonna go past those two,
As of right now, we're just doing one period.
alright.
Okay, so now, I'll show you how to get the next period later. Yes.
Okay,
Yeah.
you know how cotangent is like 0, pi, and then pi?
Hey,
So
give me, hey.
how we would put that, we would just change, like,
I'll show you that later. Okay, so now, what is halfway in between? What is halfway in between? I'm going to start on this side. What's halfway in between 0 and pi over 4? Pi over 8. So this is a positive pi over 8, right? Now, on this side, it's going to be a,
negative pi over 8.
I have a negative pi over 8 there, right?
Yes.
Okay, so now I'm going to start plugging these in. Now, because tangent is always a uniform graph, is this a positive tangent?
Yes.
No.
Yeah, where's my problem at? Where's my problem at?
Yes, it is.
There it is. It's a positive tangent, right? So positive tangent goes what way? It goes up, so it has to end up, right?
So it starts from the bottom.
Okay, so it's going to start at the bottom now.
Wait,
Okay.
it touches the asymptote?
Okay, why is the asymptote MC hammer?
Because it keeps going.
It can't touch this.
And that too.
Oh, so it's just between.
We did this.
Yes, it's going, but it's not. It's going to get close
That's what I was
to the
asking.
dotted line. That is your asymptote.
Okay, but you said there's 4 parts, right?
With Jesus.
Yes, and so we're going to start at this part right
Okay,
here.
Okay, I get it.
Now listen, please.
So where's the 4th
Hey,
part?
okay, this is a sandwich.
Okay.
That's the end of the sandwich. That's the other end of the sandwich.
I want a sandwich.
I'm going to take that sandwich. I'm going to cut it right in the middle.
Here, let's do it.
Okay? Now, and I'm going to take this piece and do what? Cut it again. Bam. Right? So, if I cut a sandwich 3 times, 1, 2, 3, how many parts do I get? There's 4 parts. 1, 2, 3, 4.
So your parts are in between.
Yes, those are my parts. Okay? So watch this. So now, at this one right here, at negative pi over 8. Okay, what is my amplitude here?
1.
1. So it means it's going to go up 1 and it's going to go down.
1.
So right here it's going to go down 1. I'm going to put a dot right there.
Oh, and then it's gonna go back to 0.
Okay, and the next one goes to 0.
Oh, this part is easy.
And right over here
1.
And then it goes back up.
goes up to 1. So right here.
Hey, so
There's our line.
Huh?
There's gonna be like 3 dots or what?
No, there's 4 dots right now.
4?
Yeah,
You're so
One,
cheesy, it's
two,
disgusting.
oh, 3.
Something like that.
But that's 3 dots.
Okay.
So wait,
Mira.
why is it-
Mira aquí. Por favor.
But we don't cut it 4 times though. You feel me?
You don't cut it 4 times.
3
You're going
times.
3 points.
That's why.
3 points gives you how many parts?
4. That's
Thank you.
okay.
What is the number? 4. 4 is the number.
Class.
We're not community.
Okay, anyway. Alright, so here's 1, 2, 3, 4. There's my 4 separate parts of this. Does that make sense?
Yes.
Okay, very good. So now I have this. Yes, my graph sucks. I'm sorry. I'm trying. Like, I really do stink at graphing tangents and cotangents.
Let's just all
So right here,
Wait.
yes,
So this is. Never mind. I'll talk to you after.
this is my tangent. Okay, so let's try another one.
I missed the math we did at the beginning.
I'm in freshman math, so I would be.
Alright, so let's take a look at this one here.
Asymptote.
I had a nice Irish teacher.
I mean, amp.
Okay, this is example 2. What's the first thing I'm going to pick out?
Amplitude.
Thank you. My amplitude is what?
Negative 3. It's negative 3.
Period.
Pi.
Is going to be what?
Pi.
Pi over 2, right?
Pi over what?
No, no, no. Over
2 over
2.
2, 1
That's
half.
it.
Is that
No.
Hold up. And then you flip it, don't you?
And then you do the math.
We're going to. I'm just writing it down.
Then it's 2 pi.
So it's going to be pi over 1 times.
2 pi. I mean 2 1, sorry.
So it's going to be.
2 pi.
So my period is 2 pi.
Okay, that's okay. This
Yeah,
is
we
the
got it.
cotangent.
So every 2 pi, it's going to.
Have an asymptote. I don't know.
Yes, it is, but it's going to do what? It's actually true. It is. It's going to repeat, isn't it? If that's my period, every 2 pi, this is going to repeat.
Okay.
No. Oh, yeah. Okay. There you go. All right. Yes. All right. So now, tangent has my natural asymptotes where?
Negative 2 pi, and then, wait, yeah.
Negative pi over 2 and pi over 2.
So we gotta keep going because it's 2 periods.
Huh?
So we gotta go keep going because it's 2 periods.
I'm only doing 1 period.
Hey, what does that stand for?
Oh, okay, never mind.
Isn't it ASYM?
A-S. Probably.
You can just write in the S and out.
Just isom, bro.
Yeah, what does that stand for?
Asymptote.
Asymptote?
I know. It's amazing what happens when people pay attention the first time I say it.
What?
I know. That's why I record it so you can say it, have it again later. All right, so now, negative pi over 2 times what?
2 pi.
Times 2. Thank you.
How?
Oh.
Don't we multiply by 1 over b, right?
Yes.
Isn't this going to be 1 divided by 1/2, which is 1,
Oh, got you. Okay, I get you. Which is what?
1, right?
Oh, you just did
Dang it. Ah. So it's going to be 1 times 2 over 1, right?
This is the 10 right next to it.
1 over b. 1 over b. I multiply by 1 over b, right?
Oh, so the one is always gonna be on top?
1 over b.
5.
Because it's 1 over b.
Okay.
Okay.
And then it's going to be what? 1 over
2.
b. Thank you. 2.
Huh?
You don't understand.
So where's the pi?
There's it's pi and negative pi.
So my asymptote is going to be at
Negative pi.
negative pi and
Pi.
thank you.
You're welcome.
Yeah, I got it. I understood this.
Now, what is my amplitude?
Negative
Negative
3.
3.
Negative 3. So if tangent goes up, negative tangent goes
Down.
Thank you. All right.
Like my grade. Huh?
Yes, like your grade. All right. So I am going to graph this now.
Megan.
Just kidding.
She went there.
Megan.
Okay.
That's all that happened.
Those are my asymptotes. All right. Those are my asymptotes.
Yes.
Yeah. You can say that.
All right. So now,
It's like
It looks pretty nice. It looks pretty nice though. Proud. You know what size left.
all right. So now, let's see if you guys can figure this out. What is halfway between 0 and pi?
Pi over 2.
And then it's a negative? Negative one.
Negative pi over 2.
And then
Got it. Hey, look at that.
What is my amplitude?
Negative 3.
negative 3.
I'm gonna be happy right now.
3 and negative 3.
So it goes up 3 and down 3, right?
Yes.
Okay. Do I have a horizontal shift?
No.
Do I have a vertical shift?
Yeah.
Nope. No phase shift and no
No.
vertical shift, right?
No.
Okay, so now, let's take a look. If this is a negative tangent, that means it has to end down, doesn't it?
Yes.
So that means this side's got to be up, isn't it?
Yes.
So there's a dot right here,
Yeah.
and there's a dot,
Right here.
and in the middle,
Yep.
right there.
Black hole.
Oh, some girl.
You know, the sad part is it gets harder. Grades right there. Grades right there.
Close enough.
Something like that.
The top one is real.
It's alright.
Isn't it just
Deep,
supposed to
deep
go
for
down?
effort.
It goes, it approaches the asymptote. Something like that, yes. I know. I'm trying on it.
Macho.
Yes.
It's the other way because
Who invented
the
math?
tan
Like,
was
this
the
is so
negative.
Green.
Okay, yes, tan is negative. Tan is negative, so it goes down. So if tan was positive, it goes up, but since it's negative, it goes down.
So it would look kind of like
Kind of like that, what I have right there.
So cotangent is the opposite. So negative cotangent was
Yes, you're right.
We're like 7 minutes left.
Good job. All right, so now, listen. Before you guys heads explode, I'm going to go ahead and stop right here on this. Okay, go ahead, Christian, close this out on the video.
Thank you guys for watching. You guys are amazing. Don't forget to like, comment, and subscribe.
Share with your
And leave the
friends.
comments on what tutorial you guys want next.
Para culeros.
Oh, good.